We're going to look in more detail now how we can work out what numbers were before percentage increases or decreases were applied to them. This can be quite tricky, not because working out the maths of percentages is difficult, but just because you've got to remember which number came first and then try and make an equation from that. Let's look at an example. I've got a laptop, it's 2 years old and is now worth about £150. This is 60% less than it was worth new. I'd like to work out what the original value was. So let's call the original value n. We don't know what it was, so we're going to call it n for new value. Our value has fallen by 60%. That's what the question says. It's fallen by 60%. This means it's now worth 40% of what it was when it was new. So we're now going to use two things to solve this question that weren't in the original question. N, we've worked that out ourselves, and the 40%, we've worked that out ourselves. So n times 40% is equal to £150. We can rearrange that so that we get n is equal to 150 divided by 40. That's just a simple algebraic rearrangement. And then of course we convert 40% into a decimal number. 40% is 40 divided by 100, which is 0.4. So n is equal to 150 divided by 0.4. So n is equal to 375. We've worked this through by applying a little bit of logic to the question. We could also have done it by taking the equation for percentage change, which is new value minus old value over old value times 100, and got the same answer. By rearranging that equation and putting the knowns into that, we'd have ended up with the same answer here. As with most of our other methods for percentages, this process will work for increases as well as decreases. So here's another example. An old painting was purchased a couple of years ago and it's increased in value by 20% and it's now worth £14,400. So can we work out what its original price was? Again, we're going to call that original price n. We don't know what it was, so we're just going to give it a letter. Our value, we're told in the question, has increased by 20%. So this means it's going to be worth 120% of what it was when it was new. That's the 100% it started with, plus the 20% increase. So it's now worth 120% of the new value. We can write that down as a mathematical equation very simply. N times 120% equals £14,400. Let's do a simple rearrangement of that now to get n on its own. So we're just going to take the 120% across to the other side. Multiplication becomes a division. And of course, 120% is the same as 1.20. We just divide by 100. So now our new equation is going to be n is equal to 14,400 divided by 1.2. And that gives us an answer of n is equal to £12,000. Questions of this kind, which are likely to be around the C grade on GCSE, are simple to work with as long as you concentrate and make sure you select the right information from the question. One way to do this is to highlight or underline the important information you're going to use. So this is a question about increases. There's a value of percentage of 20% and a numerical value of 14,400. And then we need to know what the actual question is, and that's usually the bit with a question mark on. So what was its original price? If you do this, it concentrates you on the information you really need to look at in a question, rather than being perhaps sometimes a little bit confused by large amounts of words that actually don't help you solve the question. Doesn't matter if it's an old painting or an old bike or an old car or an old boat or an old house. The maths is the important part of this question, so try and concentrate on it.